So hello dear friends, today we are going to discuss an interesting topic in the mechanics of solids, which is the Mohr circle. So in the previous class we learned about the analytical methods. Analytical method means we have derived the equation to find out the stresses in a plane at an angle of theta with the vertical, and we also calculated the stress equation for the principal stresses as well as the maximum shear stresses. So this Mohr circle is actually very interesting because it's a graphical way of solving the problems. Graphical way means we are going to represent our state of stress using a circle. So now let us go and see how the circle can be used as a used to represent the state of stress. So moving forward, so you all are familiar with the equations that we derived for the two-dimensional state of stress, right? So here, if you this is a very familiar equation to you all. We have already used this equation to calculate the normal and shear stress acting on a plane. So this was the plane that we have considered, and this is the way of representing the state of stress in this particular plane. Now I'm going to make some rearrangements here. I'm going to take this first term to the left hand side, and I'm going to square these two equations. Let us see what certainly we are going to get after squaring this. So this is the arrangement that I have made in this equation, and I will square these two equations. I will square the left hand side as well as the right hand side, and I will add these things together. So what we are going to left with is an equation like this. So I will rename this sigma x plus sigma y by 2 as average. Actually, this is the average value. I will rename this as average, sigma average, and I will rename this as r square. And if we rewrite this equation using sigma average and r, I can write the equation like this: sigma x minus sigma average whole square plus tau xy square is equal to r square. Anyway, I am going to make some more corrections here, some more arrangements here. I am going to rewrite this equation as sigma n minus. I am going to rename this sigma x because sigma n was the notation that we have used in our previous class. So sigma n minus sigma average whole square plus instead of this tau x1 by 1, I am going to write it as tau xy minus 0 the whole square is equal to r square. I have introduced a 0 here. It doesn't change anything. And if I compare this equation with the equation of a circle, I hope you all remember the Cartesian equation of a circle, which is x minus a the whole square plus y minus b the whole square is equal to r square. What is the meaning of this equation of a circle? This is the equation of a circle in which a circle whose center is at a comma b and radius is equal to r. So if you represent the circle something like this, this center is going to be a comma b and the radius is going to be r. This is how we represent a circle with the center a comma b. So if you compare these two equations, we can say that at the place of a we have sigma average and at the place of b we have 0, right? So what we can conclude is that right now, using this particular equation, we can say that we can represent this as a circle with sigma average comma 0 as the center. Definitely, we need an axis system. So the second axis is going to be tau. So this represents the x-axis and this represents the y-axis, and sigma average will be somewhere here, and this is the center. We are going to draw a circle with the radius equal to r. So this radius is going to be capital R. This is the Mohr circle. So two things we can conclude from here. One is that the average is going to be the center of the Mohr circle. Second one is radius is equal to tau max or tau min, because this is the equation that we have used to calculate the maximum shear stress. So the radius of the Mohr circle is tau max. So these are the two important conclusions we can make from this equation. Now let us move forward and see what is the actual design, not design, the drawing procedure for the Mohr circle. Actually, this Mohr circle was introduced by the German civil engineer. Credit goes to civil engineers. So the German civil engineer Otto Mohr is the one who introduced the Mohr circle, graphical way of representing the state of a system, and it was introduced in the year 1982. First, I will explain the actual procedure that was given by these engineers, and I will make some arrangements in that equation to make it much more simple. So what they have asked us to do is, first they have asked us to calculate the average value. Step number 1, we have to calculate the average value. The step number 2, we have to plot this value sigma and tau as the axis, and we are supposed to plot the average value here. This is the sigma average, comma 0 value. Then we have to find out the next point. Or in simple words, you calculate the value of r, and taking this r as the radius, if you draw a circle, you will get the Mohr circle. That is a standard procedure. And along with that, they have given one more sign convention here. And what they have stated is that if you take a shear stress like this in the x plane, if you take the x direction, sigma x, this is the tau. So if you consider the x direction, and if you have a shear stress like this, which makes the system to rotate in the clockwise direction. So if you have a shear stress like that, it is considered as negative. That means our next step, based upon the standard procedure, the next step what we are supposed to do is, you plot sigma x and you plot minus tau here. And keeping this as radius, you are supposed to draw the Mohr circle. This is how the standard procedure states. Mark the sigma average, comma 0. Then you can draw the circle using r as the radius. You calculate the value of r, take the value in a compass, draw a circle. Mohr circle is r. But here you should understand the sign convention used by the Mohr, because this type of clockwise type of shear, you are supposed to take the x direction as well as the y direction. When you take the x direction, if the shear in the x direction gives a clockwise effect, it is considered as negative. And if the stress is going to give a counterclockwise rotation, it is going to be positive. So this is how the standard procedure is stated. Now I am going to make some kind of change, some kind of alteration in the drawing procedure, which will make the things a bit more simple. So for the time being, I am going to give the value of sigma x is equal to 50 megapascal. Sigma y is going to be 30 megapascal. And I am going to take tau as 10 megapascal. Okay. What I ask you to do is, in the first step, I am asking you to take two coordinates. The coordinate should be sigma x, comma tau, and sigma y, comma tau. So when you write these two coordinates, proper sign convention has to be kept. That means if you take the x direction, 50 megapascal is going to act in the x direction. This is positive because positive x direction is considered as positive. And we have two shears here, right? The value is 10. If you look at these two shears, it is going to create a clockwise effect, so it has to be negative. So the value, first coordinate is going to be 50, comma minus 10. And if you take the y direction, this is the y direction, the value is going to be 30. This is positive, and we have the remaining two shear, these two values here, and the value is 10. It is creating an anti-clockwise effect. So the coordinate is going to be 30, comma 10. So in other words, we can say that one coordinate, one y coordinate will be positive shear, and one y coordinate is going to be negative shear. If you take any case, any application, if there is a shear stress present, one coordinate will be plus and the other one is negative. So this is how we are supposed to complete the first step. Okay, I'm making it a bit more simple for an easy construction. So right now we have got two coordinates. Now the second step is, we are going to draw two axis systems. So this is going to be the y-axis, and this is going to be the x-axis. And what another important thing is that you take the same scale for the x as well as y-axis. That means this is sigma and this is tau. So I'm going to give the same scales in the x-axis as well as y-axis. This I'm going to same. If you are taking 1 centimeter is equal to 10 Newton, then in the same scale, 1 centimeter is equal to 10 Newton has to be adopted in the y-axis also. So this is how, and we are going to mark this 10, 30, 50. All these things will be there. Similarly, this is plus 10, this is minus 10, like this. So in the next step, what you are supposed to do is you are supposed to plot these two coordinates in the graph or in the plot. That means 30, 10. So 30 is this value, 10 is going to be these two values. So this point is going to be 30, 10. Similarly, 50, minus 10 is going to come somewhere here. 50, minus 10. And the next step is join these together. You are supposed to join these together. So the point where this line crosses the x-axis is automatically going to be the value of sigma average. So if you take the 50 and 30, what is the average value? 40, right? 50 plus 30 by 2. 40 is the average value. So that 40 has already obtained here. So I'm just deviating from the actual procedure. I'm giving you some simple methodology to draw the Mohr circle. So right now this is the center, right? Take the compass, keep this as center, this is radius, draw a circle. This is the Mohr circle. The easiest way of drawing the Mohr circle. So write two coordinates, plot those two coordinates, join them together. The intersecting point in the x-axis is the center. That is inbuilt. That is going to be the sigma average. Keeping that as center, draw a circle. That is the Mohr circle. It's the easiest way of understanding the Mohr circle. Okay. Now, after completing the Mohr circle, certain things you should keep in your mind. First thing is that, see, once the Mohr circle is over, the diameter that we have joined right now, this diameter is going to be the reference line that we are going to take, not the actual sigma axis. No, we are not going to use this axis anymore. So now to calculate anything related to the stress system, we need a reference line, and that reference line is going to be this diameter, and that is very important because you cannot measure anything from the actual x-axis. No, that is not the way we are going to do it. This is the way we are going to do it. So this is the new reference axis, and this point is starting from 0, and this is representing 90. Why? Because if you look at the 50 and 30, these two are acting on a plane which is perpendicular to each other, right? So if you look here, this value is going to be 50. Sigma x is going to be 50. Somewhere it is going to be 50. And this represents something 30. But look at the Mohr circle. In the axis system, it was separated by an angle 90, but here they are separated by an angle of 180 degrees. So that's a very, very important point that you should keep in your mind. If you want to represent a plane in the actual system, then you have to take double the angle in the Mohr circle and vice versa. If you measure some angle in the Mohr circle, the actual angle is going to be half of this value. So that is what I have explained here. 50 and 30 is separated by 90 degrees in the actual system, but when it comes to the case of Mohr circle, it has changed to 180 degrees. So if you take any angle into the Mohr circle, the value will double, and if you want to take out anything from the Mohr circle, you have to take the half the value. I think it's clear. Okay. Now, that is one important point you have to keep in your mind regarding the new axis system. Now we have to learn how we can find the normal and shear stress acting on a particular plane. That is the next point of discussion. So how can we find that? So now the question is, what is the stress in an inclined plane? That's a very interesting question. So we will start from the previous one. So we have constructed the Mohr circle, right? Let us say that this is going to be the Mohr circle. I have a Mohr circle here, right? And this is the reference line that I have selected. I will do one thing. I will draw a straight line itself to avoid some confusion. I will draw a straight line. I will draw a straight line like this, right? Now this is going to be the reference line. So, and I want the stress. It is acting on a plane inclined at 30 degrees. I want to have the value of It's normal and shear stress acting on this particular plane. I hope, try to remember what I have taught you in the previous slide. I told you that if you want to represent this particular plane in the Mohr circle, you have to double the value. So what is the value? Or this 30 should be represented as 60 in the Mohr circle. So take the double of this actual value. So what is that value? 60 degree. What you do? From here, you measure 60 degrees. Okay. And you join, extend this line. It is going to meet your Mohr circle at some particular point. Okay. So this is the actual plane that represents the one in our question. So corresponding to this 30 plane, we have to take an angle of 60 degree, join a line. It is going to meet somewhere here in the Mohr circle, and that represents the corresponding point. Now, how can we get the value of normal stress and shear stress? It's very easy. From here, you drop a vertical line. The meeting point is going to be sigma n. And from here, you drop a horizontal line to the y-axis. The meeting point is going to be tau. Same thing that we have found using the analytical method. It's very simple. Suppose if you have, let us take another example. Let us find out the value in some other plane. Yeah, right now we have found the value of the stress in acting at an angle of 30 degree. Now let's say let us change this 30 to some other value. Let us say the value at 60 degree. Oh. I will go with the 45 degree. Okay. So this 45 degree will be represented as 90 degree in the Mohr circle. So what I will do from here, I will in the anti-clockwise direction I will measure 90. So this is going to be 90 degree, right? Now what I will do from here, you drop a vertical line. The meeting point is going to be sigma n, and from here you extend a horizontal line. The meeting point is going to be. It's very simple, but only one thing, everything has to be measured from this reference line. You should not use the x-axis as the reference. So right now we got the value of sigma n, and so this is how we are going to find the value of stress. That is being shown here. See, they have taken the value 2 theta from the reference axis, and they got this particular point. This is the point. From here, you extend here, you will get the value of sigma. You will get the value of sigma n, and this is going to be the value of tau. This is how we find the actual stress in a plane. Now, right now we calculated the stresses acting on a particular plane. Now the question is, how can we calculate the principal stress? That is also very interesting. So let us calculate the principal stress. That is directly obtained from the Mohr circle. How? Look here. See, you have constructed a Mohr circle, right? We have two coordinates, join them together. This was the average value, keeping the center. We have constructed a circle, right? And see the point where the circle meets the reference axis. Here, this is the point where the circle meets the reference x-axis. This is going to be the value of sigma 1, and this is going to be the value of sigma 2. Why? Because sigma 1 is a major value. So this is going to be the major value, and this is going to be the minor value. So from here, you measure the value. This is going to be sigma 1, and this is going to be sigma 2. It's very simple. Now you might be wondering, how can we find out the theta p1, right? That is also very easy, because this is the reference line. From here, what I will do, from the sigma 1, I will join towards the center. So this is the principal plane. From here, I will measure in the anti-clockwise direction. This value is going to be 2 theta p1. Similarly, from sigma 2, I will join towards the center. From here, in the counterclockwise direction, I will measure. This is going to be 2 theta p2. If you recollect what we have learned in the previous class, I told you that theta p2 is equal to theta p1 plus 90 degree. But if we consider, or if we take this case in the Mohr circle, it has to be double the value. You check here, sigma 1 is here, sigma 2 is here. They are separated by 180 degree. In the active system, it is separated by 90 degree. So for every angle, this doubling effect is there. So when you take a value out of the Mohr circle, you have to half the value. And if you want to represent something into the Mohr circle, you have to take the double of it. Right now, I have taken the value of principal planes from the Mohr circle. So this value is going to be double. So the actual value will be half of this. This is how I am going to measure the value of principal stresses as well as the corresponding planes. Now, obviously, the last thing that we are supposed to find out is the maximum shear value. That I have already explained, that the radius of the Mohr circle is going to be the maximum shear value. So this is going to be the maximum shear value. This is the maximum shear value. This is the maximum visible tau max. This is not tau minimum, this is tau max. Based upon our representation, that is tau max, and this is going to be tau minimum. Numerically, they are same. And from here itself, I will measure 2 theta in the anti-clockwise direction. So the actual angle is going to be half of this angle measured in the Mohr circle. So this is how we find the normal stress, shear stress, maximum principal stress, minimum principal stress, maximum and minimum shear stresses, and their corresponding angles in the Mohr circle. So you practice, you take a question, you practice it, and get the values. Okay, you look at this question. So right now we have a stress value of 80 compressive in the x direction and 50 tensile in the y direction, and we have a shear of 25. Now, based upon our procedure, how will we do? I will consider the x direction. So if I consider the x direction, 80 is compressive, so I will take it as minus 80. And if I take the x shear, this is the x shear, they are creating a counterclockwise effect. So the value is going to be plus 25. Right? Second, if you take the y coordinate, the value is 50 tensile positive. So the first value is tensile positive. And if you take the shear in the y direction, it is creating a clockwise effect. Obviously, it has to be minus 25. Anyway, we have represented this as plus 25. Obviously, the next value is going to be negative 20. What is the next step? Plotting these two values. So this is going to be what? This is going to be 80. This coordinate is going to be 80, minus 80 and 25. This is going to be 50 and minus 25. I join these two lines here. This is the center. Keeping this as a center, I completed a circle. It is a Mohr circle. Now, this point is the one which is intersected with the x-axis is sigma 1. The negative value is going to be the sigma 2. This is going to be 2 theta p1, and this is going to be 2 theta p2. This is the tau max, and this is going to be the tau minimum. From here, I take this angle. This is going to be 2 theta s1. And from here, if I represent like this, this is going to be 2 theta s2. Right? You take the scale, you make the proper measurement, you will get the answer directly. There is no need to have a calculator. Graphically, you can easily calculate all the values and you can find the corresponding angle. So, to try to practice this in this way, you will find it more easy to follow. So, you take an example and try to solve it. Okay, for the time being, I will show you one more example. Let us take a stress system. Let us say that this is going to be some 20, and we have a compressive value here, which is nothing but 40, and I have a shear here represented by 10. Okay, if I write two coordinates, the value is going to be 20 plus 10 and minus 40 minus 10. How will I represent this? I have an x and y axis here. This represents sigma, this represents tau. So, minus 40, 10 is going to come somewhere here. Right? This is going to be minus 40, minus 10. 20, 10 is going to come somewhere here. This is going to be 20, 10. So, if I join these two together, this is going to be the sigma average value. Keeping this as center, I will draw a circle. The circle is not good. Okay, let us say a better one. Okay, fine. So, the point where it meets this point is sigma 1. This is going to be sigma 2. So, this is going to be the new reference line. So, from here, you can measure 2 theta p1. This is going to be 2 theta P2. This is going to be the tau max. This is going to be the tau. This is how we calculate the corresponding principal stresses as well as the stress in a particular plane. So try to practice to take any question. It's easy to solve. So when you try to solve in a two-dimensional state of stress question or principal state of question, you solve it analytically and validate by using Mohr circle, or you solve by using Mohr circle and try to validate by using the analytical method. So that's in that way you can easily calculate everything, and you can have a better idea about the state of stresses in the acting on a different way. So that's all for today's class. So enjoy constructing Mohr circle. Try to solve some other questions, and we'll catch you up in the next class with some other topic, some other interesting topic. So bye for now. Thank you.